All right, so in this lesson, we're going to learn all about how to identify the transformations from an equation. If you recall from the previous lesson, we had already done that with looking at the graphs. We're now going to do it by looking solely at the equations. So for our transformations, the first one, if you're adding a number outside of the function, so f of x plus b, then that's going to be a vertical shift, and that's going to be up by 5, or up by b. So up by b, and then for the type, that's a vertical shift. And that's also the same for when you're subtracting by b. It's just the opposite, and you probably have already figured out that that's just where we go down by b. All right, for our next one, if you're multiplying by a number in front of the function, you're going to have either a vertical stretch or a compression, or sometimes called a shrink. If that number is larger than 1, so this is kind of the key part right here. If a is greater than 1, then that's going to be a vertical stretch by a. Now, vertical stretch by a, again, that's because a is greater than 1. If it's a number between 0 and 1, so think about numbers between 0 and 1, those would be fractions, those would be decimals, then instead of a stretch, we're going to shrink our graph. So a vertical shrink by whatever a is. This is also sometimes called a vertical compression. So if you hear me say vertical compression, that's what I'm referring to, but they are the same thing. Okay, let's take a look on the other side. So a negative in front, we saw this in our graphs. This is a reflection over our x-axis. I'm going to add one to this if the negative is inside the function, meaning that it's directly in front of the variable, then that's a reflection over the y-axis. All right, our last two here, if you have f of, in parentheses, x plus b. In parentheses, you want to think opposite. And so plus b actually moves you to the left by b. This is a horizontal shift, or a horizontal, sometimes called a horizontal translation. And then if you have f of, in parentheses, x minus b, that actually moves you to the right by b. And again, a horizontal translation is what that's called. So those are the two that you really have to be careful of. I'm going to put a star next to each of those. Those are the two that you'll probably have to do some practice with remembering, is that it's always going to be opposite when you're looking inside the parentheses. So if you see plus, you actually want to think left, minus, you want to think right. So let's do some practice with these. We're first going to, kind of like before with the graphs, identify what the function is, so whether it's linear, quadratic, and so on, and then we're going to describe the transformations that we see. So number 1, f of x is equal to 4 multiplied by the square root of x. Okay, well, there's our type. It's a radical function because of the square root sign. And for the transformations, we're multiplying by a number in front of our parent function. Remember, our parent function is the square root of x. And so if that's the case, that number being multiplied in front is bigger than 1. So we're going to say that that is a vertical stretch by that number, so vertical stretch by 4. All right, on number 2, for type, let's look at where our variable is. In this case, our variable is as an exponent, so our type is exponential. Remember, the parent function is a multiplied by b to the power of x. We've got a negative in front of our parent function, and it's not directly in front of the variable. So a negative in front of our parent function, that would be this right here, tells us that we reflect over our x-axis. All right, taking a look at number 3. So for type, let's look and see our variable is being raised to a power of 2. That power of 2 does not make it exponential. That power of 2 makes it quadratic. And our parent function is x squared. So our addition by 4 is inside the parentheses. So addition inside the parentheses, that would be this right here. That tells us that we're actually going to move to the left by that number. So left by 4. All right, let's take a look at a few more. So on number 4, we've got f of x is equal to 3x plus 44. This time variables by itself doesn't really have anything happening to it, being multiplied by 3, but that just makes this a linear equation, plain and simple. So again, our parent function is just x by itself. So really we've got two things that are going on here. We've got multiplication in front of the variable, and we've got addition after the parent function. So there's going to be two things that we need to talk about. The multiplication in front is bigger than 1, so that does make this a vertical stretch by 3. Also, we've got a plus 44 after the function. So addition after the function, that would be this transformation right here. That tells us we're moving up by whatever that variable or that number is, so up by 44. All right, let's take a look at another one. So on number 5, f of x is equal to 1 over x minus 2. Notice that the variable's in the denominator, it's written as a fraction. Fractions are ratios, so this is a rational function. So our parent function is 1 over x. So if we think about what's happening, the minus 2 is happening inside of our parent function. It's happening within the fraction. So it might help to put that in parentheses like I have, to think about what the transformation is. We've got subtraction inside the parentheses. So subtraction inside the parent function is going to be right by whatever that number is, so right by 2. In fact, that is the only transformation. There was just an extra blank. One more thing that we're going to look at. For number 6, type should be pretty easy to identify. This is a logarithmic. Parent function is log of x. Sometimes that's written log base 10 of x. So really what that means is that this 10 that's in the middle really doesn't have to be there. So it's not got any transformation. Okay, so let's look at our two transformations that we do have. We're multiplying by a number in front, subtracting by a number at the end. So multiplying by the number in front, 2/3 is between 0 and 1. So that tells us it's going to be this transformation. That means it's a vertical shrink by whatever that number is. So vertical shrink by 2/3. And then the minus 3 that comes after it, that would be the minus after your parent function. So that would be down by whatever that number is, so down by 3. Okay, so just a little bit more practice. In fact, if you wanted to pause the video and see if you remember these different types and what their names were, feel free to do that. I'm going to give you just a second if you'd like to, and then I will go ahead and name each of these functions. All right, so number 7, this is a rational graph. You can tell because of the two pieces, all of that kind of stuff. For number 8, you have to kind of look very closely. It does actually start at a single point, so even though it's been moved, this is still a radical function. And then lastly, for number 9, you can see that it actually continues. Because it continues to go down over here and doesn't just start at some point up here, that's your clue that this should have been a logarithmic. All right, that is it for this lesson on transformations. Until next time, have a great day.